Napier, Malcolm, was it 2 or 3 RdgGeeks ago, said to me, I've got a rep wrap, yes. So yeah, I'm really excited about this, and Malcolm very kindly printed this somewhere. About too much. Suspicious. But little RdgGeek thing, so I'm really pleased with that. So, Malcolm.
Thank you. Firstly, credit where credit's due. You'll see my daughter Hannah gets credits on this presentation, because over in the far corner we have a working 3D printer, and she's the person who built it. And we also have the framework of a second one, which is our attempt to prove that our printer will replicate. So if you're interested after the presentation, we're planning on hanging around afterwards as well. We'll probably set a print run running. We're not running it at the moment because the acoustics, etc. in this room aren't particularly good, and it is a little bit noisy, particularly if it's printed in a complicated shape. So before I start, can I just do a check as to what sort of mix of audience we've got? How many people would call themselves hardware maker geeks, people who mainly deal in physical stuff? Okay, minority. Software. Good. And anybody who classify themselves as somewhere in between, maybe electronics type person?
I'm here for the beer, but I'm driving, so I've got to...
Fair enough. Okay. What I'm planning on doing is doing a sort of run through how you get to 3D printing in the first place, just to set the context, because I wasn't sure when I was coming to print here, to talk here, how au fait people were with the 3D printing revolution. So I'm going to do an age survey covertly here. Who remembers this life? Yeah, so we're talking about a world without the desktop printer, and I'm guessing a lot of people here can't remember that age, but quite a few of us can, and I can remember having to take any document I produced down to a typing pool, getting something back that looked like that, because we had physical files, and you had to put different copies in different files. The document looked pretty naff, and if you wanted multiple copies, you had to design something completely different and find somebody willing to sit there cranking the handle until you got the prerequisite number of copies. I'm not that old, surprisingly, and this is what, 25 years ago. It's not that long ago, and think about the changes to the printed word, to how people treat documents, the quality of documents we can all produce, and to the price of the production of those documents that Mr. Hewlett and Mr. Packard made when they first made their desktop printers. So we, as a company, we're actually quite interested in how people learn about the effects that these sorts of disruptive technologies can have. And we happen to think that there's a pretty disruptive technology coming along in the form of desktop printing of physical objects. And we've had a few questions along the way, particularly when people were asking about what the presentation was about. Well, is it some sort of 3D film? It's something you look at that projects a 3D image. We're actually talking about physical objects. I'm going to pass these 3 round. That's something we've printed between 7:30 and 8:15 today. No finishing, no adjustments, nothing else. That'll give you an idea of the quality that's achievable with a machine you can build yourself for £500–600. So if you'd like to have a look at that, pass that around. That, although it looks pretty innocuous, is our calibration benchmark. And why that's significant is because it actually will hold liquid. So there are no holes, there's no permeability in the plastic. And finally, the one that seemed to attract the most interest when people were coming over and looking, this is a part that's printed as a single part, but actually is a plastic ball bearing. I mean, engineering-wise, it's pretty crap quality, but these things are only going to get better. And if you can print that now, what are you going to be able to do in 2 or 3 years' time? So just to try and set some sort of context as to where this lot's coming from, how did we make things in the beginning? Well, we put things together, we added them. when we got to the Iron Age, we worked out how to make things hot and melt them, and having melted them we could pour them into shapes. We could take a block of something and we could extract, remove the stuff, or certain materials we could actually mould to particular shapes or patterns. And then we got mechanical. So who can match what to what? I mean, I think I'll give you that one because that's still making cloth. And the steel making technology hasn't changed much from the Iron Age, really. What are the other two? What's that machine doing? Yeah, and what does it do? Which of the previous pictures does it correspond to? You remove material, that's right. And what's that one? No, that's a press. It's a press. And that shapes the material by stamping it out. So once you get mechanical forces involved, the stuff you can do is actually pretty significant. Then we got IT came around, and we were able to do computer drawings. So rather than the artwork we saw earlier, dull, boring, schematic engineering drawings, then people got a bit more clever and they were able to create 3D shapes and put them together so you could work out whether your components had fit together before they were actually made. And then we got to a point where the computer could control the machine, and what you designed here, you just put it as a program on the machine. And this is a subtractive process. You put a block of metal in there and it grinds all the bits off that you don't want. There was an intermediate stage where if you just remove the picture, you're breaking the screen. If you remove the computer from the picture, that was numerical control, but that only lasted for a few minutes really in the scale of everything. So then we got a little bit more clever. The sort of key thing here is that we're beginning to move into the world of 3D printing that I'm really going to talk about, because we're doing things by adding them together. And there's a whole pile of different technologies, all of which are being patented by particular people, so they keep them tight and they generally charge you a lot of money for using them. Laser sintering, just to pick a couple of examples, is where you have a powder and you point the laser in the pattern that you want into the powder. The powder fuses, the powder bed drops a short distance, some more powder is dusted over the top, and the process is repeated. So it builds things up by layers. Fused deposition modelling, I'd like to remember FDM for a little bit later on, but that's the similar technology to what we use in our printer, and there you squeeze heated plastic. So it's, the way I think about it, it's a bit like sealing the edge of your bath. You've got your gun, you squeeze the gun, a bead comes out, you put it around the edge of the bath, it goes solid. Well, if you were doing that on multiple layers, then you'd be doing fused deposition modelling. And that works with plastics that go wobbly when you heat them, or low melting point metals like solder. And stereolithography is similar to selective laser sintering, except that you fire your laser into a liquid resin, and the shape solidifies. The laser causes the resin to solidify, so then you drain the bath of material and you end up with your physical shape. But there's loads of these, and the acronym developers had a field day basically. So when does a prototyping device become a manufacturing device? And what if you've got a machine that you can actually fire a laser into some stuff and it makes you the part that you want? Do you have to go through a mass production process? And so there's a concept that's recently come into being, the concept of direct manufacturing. And it's, hey guys, why do we bother with all these factories and stuff like that? In a world which is increasingly customised, where people want their own individual, whatever it is, let's say push bike to To pick on an example that was recently demonstrated on telly, you can create your own design on a computer, send it off to somebody, and they'll print you out an absolutely unique bike. And that becomes direct manufacturing. And I'm not sure how much the bike will cost because it uses aerospace technology. But it was on the aerospace printers, the sort of printers they use because they only make planes in 1s, 2s and 3s. You can actually do that in Bristol. They've got a big machine, probably with a printing area about the size of this screen and about that wide. They actually normally print real parts for aeroplanes, but as a joke, somebody designed a bike, and its idea was very similar to the roller bearing. They actually printed the bike out on job, just got on it and rode it. Well, no. Well, sorry, it did not have tyres, but you could ride it on the wheels that were printed. I'm not sure how comfortable it would be, and no, it didn't have suspension either. But we get to really what the main thrust of this talk is about. When it's small and it's low cost, well, we reckon that the working machine over there cost about £600 to make. And when we get to our second machine, we reckon that would have cost £250 in parts. I mean, labour's a different matter. With the first machine we were on and off for 5 years, so how you cost that amount of timing, but we'd be a lot faster building the second one.